Hello ladies and gentlemen. Today I was going to post some equation problems, but I decided to teach a few methods first, because if you know these methods, then solving some of these systems of equations will not look as much of a mystery as it might look now. So we wanted to see if there is a systematic method to solve equations like these three. And each of these systems of equations have a specific characteristic that is unique to them, and we can use that characteristic to solve the problem in an efficient way. For example, the first system of equations, the first equation in it has both first order and second order terms, but the second equation is only first order. So for equations like this that one of the equations in the system is first order, what we can do is to find one of the variables in terms of the other variable from the first order equation and then replace it in the other equation and be hopeful that we can solve the resulting second, third, or fourth order equation that comes out. In this case of this example, it's just second order, so it should be straightforward. So in order to solve it, we can just say, let me just rewrite the equation. So this is equation 1. We have x squared plus y squared plus 4x minus 6y is 13. And we can rewrite the second equation to be, if I move y to the other side, it will be 3x minus 1 is 2y, and therefore y will be 3x minus 1 over 2. Now if I replace y into the first equation, I will have x squared plus 3x minus 1 over 2 squared plus 4x minus 6. 3x minus 1 over 2 is 13. Now we need to simplify this, which I guess it should be not that hard. So the first term is x squared. Second term will be 9x squared minus 6x plus 1 over 4 plus 4x. And this 2 and 6 will give us 3 minus 9x plus 3 is 13. So right off the bat, we can simplify these two terms and get minus 5x, and this will give us 10. Now I can multiply both sides by 4, so we get 4x squared plus 9x squared minus 6x plus 1 minus 4 times minus 5 is 20x, and 4 times 10 is 40. So then we get 13x squared minus 26x minus 39 equals to 0. Right. And then we can see that if we factor out 13 minus 2x minus 3 will be 0. So therefore the equation will simplify to x squared minus 2x minus 3 equals to 0. And in one of the previous problems, we showed that if sum of a and c is equal to b, then one of the roots is minus 1 and the other root is minus c over a, which will give us 3. So if we want to check our answers, we can plug minus 1 into this, which will give us 1 plus 2 minus 3, which will be 0, and then 9 minus 6 minus 3, which again is 0. So these two are the roots of the equation. And when we have x1 and x2, we know that the relation between x and y is this. So we will get y1 will be 3 times minus 1, which is minus 3 minus 1 divided by 2, which makes it minus 2. And y2 will be 3 times 3, 9 minus 1 divided by 2. And this is 8 divided by 2, which makes it 4. So the answers to the equation are these pairs. X1 equals to -1 and y1 equals to -2 and x2 equals to 3 and y2 equals to 4. So this is the first method for solving nonlinear systems of equations that one of the equations is first order. In this case, again, the first equation was second order, so solving it was straightforward. If the first equation has a higher order, then we may need to use factorization or use some other kind of method to solve it. It will be more complicated. Now, let's look at the second equation. Both of the equations in this system of equations have higher order than 1, and therefore it's not going to be easy to find one variable in terms of the other one and place it in the second equation. But if we look at them a little bit more carefully, both of the equations in this system are symmetric, meaning that if I swap the location of x and y, I will get the same equation. We solved a few simpler equations like this before. It wasn't a system of equations, it was just one equation. And whenever we have symmetry between the two variables, we can assume that x and y are the roots of a second order equation. And then we can write the system in terms of the sum and product of the roots of that second order equation. So let's try that on this. I need to rewrite this equation. So it's, let's go here, 2 was x squared plus y squared equal to 7 minus xy, 7 minus xy. And the second equation was x plus y minus 2xy is 11. X plus y minus 2xy is 11. Let's assume that x and y are roots of a quadratic equation, and therefore x plus y is s, sum of the roots, and xy is p. So now let's replace these into this equation. From the previous problem that we solved, I'm going to post the problem number in the comment section. We know that x squared plus y squared is s squared minus 2p. So we will get, I'm just rewriting this equation in terms of s and p. We will have s squared minus 2p will be 7 minus p, and s minus 2p will be 11. Therefore, s squared minus p is 7 and s minus 2p is 11. Now you see that symmetric equation that we started with turned into a system of equations of the first type that we talked about. This second equation is first order now, and therefore we can find s from it. S will be 11 plus 2p, and replace it into the first equation. So we get 11 plus 2p squared minus p is 7. So 121 plus 44p plus 4p squared minus p will be 7. And from there, 4p squared plus 43p plus 114 will be 0. And now we need to solve this equation. So p will be minus b, which is 43, plus minus b squared, which is 43 squared, minus 4 times a times c, divided by 2 times a, which is 4. And this will be minus 43 plus minus t5 divided by 8. So P will be minus 43 plus minus, 25, I wrote 27. 5 divided by 8. So P1 will be minus 48 divided by 8, which is minus 6, and P2 will be minus 38 divided by 8, which is minus 19 over 4. Now, we know that S is 11 plus 2P, and therefore, if P1 is minus 6, then S1 will be 11 plus 2 times minus 6, which is 11 minus 12 is minus 1. And if P2 is minus 19 over 4, then S1 is 11 plus 2 times minus 19 over 4, which is, this 2 cancels with 4 and gives us 2, so we'll have 22 minus 19 over 2, which is 3 over 2. So these are S and P's that we will get. Now, we need to find X and Y. And we knew that from our original assumption, X plus Y is P and X plus 1 is S and XY is P. We also know that if we know the sum and product of the roots of a second order equation, we can make that equation from knowing the sum and product. So if the equation is ax plus b, ax squared plus bx plus c is 0, if I factor a, we will have x squared plus b over a, x plus c over a equals to 0. And we know that s is minus b over a and p is c over a, so x squared minus s x plus p equals to 0 will be our equation. So let's form that equation. So we need to form two equations, one for each of these sets of S and P's. So for case 1, or for equation 1, where P is minus 6 and S is minus 1, the equation will be x squared, or let's call it z, just so that it is different from x and y. So z squared plus z minus 6 is equal to 0. And from here, we will have z is minus 1 plus minus 1 minus 4 times minus 6 divided by 2, which is minus 1 plus minus 5 divided by 2. And therefore, x1 will be 4 divided by 2, which is 2. And y1 will be minus 6 divided by 2, which is minus 3. Now, we should remember that because the equation was symmetric, we can reverse the order of x and y. So alternatively, x1 could be minus 3 and y1 could be 2. Now let's form the second equation for the second set of S and P's that we found. So P2 is minus 19 over 4 and S2 was 3 over 2. So then the equation will be z squared minus 3 over 2 z minus 19 over 4 is 0. And if we multiply the two sides by 4, we get 4z squared minus 6z minus 19 is 0. So z will be plus 6 plus minus square root of 36 minus 4 times minus 19 divided by 8, which is 6 plus minus 340 divided by 8. But then 340 is divisible by 4, so we can rewrite this as 6 plus minus 2 square root of 85 divided by 8, and that will give us x1 is 3 plus root 85 divided by 4, and actually let's call this x2. y2 is 3 minus root 85 divided by 4. Again, x and y can swap because the original equation was symmetric. So now let's look at the third type of equation. The third type of equation is not symmetric because this second equation is not symmetric, but it is homogeneous. And when it is homogeneous, it means that we should be able to write an equation out of these two that is a second order equation. For example, in case of this, so if I assume that y is mx and I replace y inside these two equations, I will get a system of equations that is based on x squared and m, and maybe we can solve it that way. So let me rewrite this. The equation is, so this is the third type of system of nonlinear equations. So it was 2x squared plus 3xy plus y squared is 70, and 6x squared plus xy minus y squared is 50. And we want to say y is mx. And then we replace this into the two equations. So we get 2x2 plus 3mx squared plus m squared x squared equals to 70. And then 6x squared plus mx squared minus m squared x squared is 50. So as you can see, now I can factor out x squared from the two equations. So we have x squared, 2 plus 3m plus m squared is 70, and x squared, 6 times 6 plus m minus m squared is 50. Now if I divide these two by each other, x squared will cancel and I will have a second order equation. So this seems to be a neat trick that we decided to set y equals to mx. So let's divide them by together. It will be x squared times 2 plus 3m plus m squared divided by x squared, 6 plus m minus m squared is 70 divided by 50, and the x squareds will cancel. Now if I multiply these sides by each other, the equality will still hold, and 70 and 50 can be simplified to 7 over 5. We will get 10 plus 15m plus 5m squared is equal to 42 plus 7m minus 7m squared. Now if we bring everything to the left hand side, we will have 12m squared plus 8m minus 32 will be 0, and this is 3m squared plus 2m minus 8 is 0. So m will be minus 2 plus and minus 4 times 3 times minus 8 divided by 2 times 3, and this is going to be minus 2 plus minus 4 plus 96 over 6, which will be minus 2 plus minus 10 over 6. Therefore m1 will be minus 12 over 6, which is minus 2, and m2 will be 8 over 6, which will be 4 over 3. So we found m. Now after finding m, we can replace m into these two equations and find x we have 2x squared plus 3m plus 3, let's say m is minus 2, minus 2x, so plus 3, oh sorry, x squared, plus m squared x squared plus 4x squared is 70. So simplifying this will give us, this is 6x squared and this is minus 6 squared, so will give us 0 equals to 70. So m equal to 2 is actually not acceptable, so will result in an impossible equality. Therefore m equal to minus 2 is not an answer. And this time if m is 4 over 3, we get 2x2 plus 3, 4 over 3 x squared plus, I think it was m squared, yeah, m squared, which is 4 over 3 squared x squared is 70. And from here this 3 cancels with this 3, so we'll have 6x squared plus 16 over 9 x squared is 70. Therefore 54 x squared plus 16 x squared over 9 will be 70. So 70 x squared will be 70 times 9. This 70 will cancel with this 70, and x will be plus or minus 3. And now we know that y was mx, so y will be 4 over 3 times plus or minus 3, should be plus or minus 4. So this actually solves the third equation. It is useful to check our answers by placing the roots that we found into the original equations and see if they satisfy it, because whenever we have something that something artificial that we raise to the power of 2, we may insert additional roots that are not real roots of the system. So it's always good to check the answers. So let's go back to the original 3 equations that we had and kind of summarize what we just learned. So there are many kinds of nonlinear systems of equations. Some of them may not even be solvable, but in some cases the equations are simpler and we can categorize them into 3 different types. The first type that we talked about here is a high order equation for the first equation of the system, and then a linear equation, the first order equation, for the second. And in order to solve this, we find one of the variables in terms of the other and place it in the high order equation and solve that. The second type is a symmetric equation, which means if we swap the location of x and y, we will get the same equation. And in order to solve this, we will assume that x and y are the roots of a second order equation, and we use sum and product of the roots to simplify the equation and make it simplified into the first type of equation, and then we solve it. And the third type was a homogeneous equation, which means all of the terms in both of the equations have the same order, and in order to solve that, we just assume that y is m times x. We replace this into both equations, divide them by each other, x squared will cancel out, and then we simplify the resulting equation in terms of m and we solve that, and after that we can find x and y from there. Well, I hope you like these methods. I'm going to post some practice problems after this, and you can decide for yourself which type of equation is the practice problem and use one of these 3 methods to solve them. Again, I hope you like this, and thank you for watching.